what is the stress induced in the rod if it is allowed to expand by 4 mm, and E and alpha values are given. Okay, so here, so see, there is a rod. Okay, initially I have taken a rod like this. So at 20 degree, so initially the temperature is 20 degrees centigrade, and it is how much length? 10 meter long. Okay, and after that what I did, I made it to be 60 degrees centigrade. Then what happened? It will automatically expand. When it is expanding, because of the temperature rise, what is the amount of expansion? What is the amount of expansion, or expansion in the sense elongation of the rod? What is the elongation of the rod? The delta equal to L alpha delta T. Okay, so how much it is? So L is a 10. Okay, let's keep this. So what is the meaning of this? The delta is L alpha T, and if you calculate this, let's calculate, let's see how much it is coming. So this is a 10 meter, and what is the alpha value that is given? Here I will write alpha value. Alpha value given is a 12 into 10 power minus 6 per degree centigrade, and E value also given, that is a 200 gigapascal. Okay, so finally what we need to find out here? So we need to find out the amount of stress that is produced in the body. Okay, we will see that. And if I substitute this, L is a 10 meter, alpha is 12 into 10 power minus 6 per degree centigrade into delta T, the difference between these two, that is a 40. Okay, so how much it will become? So delta will become, this is in the meter, and if I multiply with a 10 power minus 3, then it will become millimeter. Okay, millimeter, because the length is in the meter. Then how many zeros are there? 1, 2, 5. Okay, so you do the calculation part, and finally you will get a 4.8. 4 into 12, how much? 40. 2 into 4, 8. 4.8 mm. Okay, so you are getting 4.8 mm elongation. When the temperature of the body is raised, that much it got elongated. Okay, that much it got elongated. But here there is a twist in the problem. What is that? We already discussed while dealing the theory. What is that? The body, when it is trying to elongate, we allowed it for 4 mm. So it is allowed for 4 mm free expansion. So because of the temperature rise, the body is trying to elongate, and when it is trying to elongate, we allowed it without any restriction up to 4 mm, and after that what we did, we restricted it. So what is happening in this case? So body is let's say it is expanding on both sides, but for the sake of understanding, I will say that it is expanding only on the one side. So it is without any restriction, it is expanding up to the 4.8. But what happened? Only up to 4.8 I allowed, and after that I kept some restriction. So this is only up to 4. So this much is not allowed. We are not allowing. I kept the restriction. So whenever there is a restriction, then what happens? Whenever there is a restriction, then automatically the internal opposition will start. Then it will produce the stress. Okay. So the internal opposition starting only after 4. Why? Because I kept the restriction. So that means the amount responsible for sigma, that means stress produced in the body is from 4 to 4.8. understood? Okay, the elongation, the new elongation, let's say this is a delta 1 is a 4.8 minus 4, that means 0.8. okay, this 0.8 See, when we rise the temperature of the body, instead of 4.8, if it is expanding only 3, then is there any possibility of producing the stress in that? No. Why? Because the body is allowed up to the 4 mm free expansion. But whenever the body is expanding beyond the allowable 4 mm free expansion, then only it will produce the stress, and we need to consider only that extra elongation. That extra elongation here is 4.8 minus 4. Okay, that is 0.8. So here, what is the 0.8? Delta 1 equal to 0.8 delta 1. So delta 1 divided by L is nothing but 0.8 divided by 10. This is nothing but what? Strain. Okay, this is the strain that causes the stress. Okay, and then stress equal to how much? Stress equal to E into capital E. Okay, then if I substitute this value 200 gigapascal 10 power 9 into what is the E value? E value is 0.8 mm here. This is in the mm, so 10 power minus 3 divided by L. L is how much? L is a 10 meter. 10. Okay, so 2 into, see, if I take this one 10 power minus 4 and I also add one 0.8 also here, then it will become 10 power minus 3 minus 5, 10 power minus 5. So here what I do is 2 into 8 is 16 into, I will add these two zeros to this, then how much it will become? 10 power 11, and here 10 power minus 5. Then finally how much it is becoming? 10 power 11 minus 5. Okay, it will become something like a 6. Okay, 10 power 6. That means sigma equal to 16 megapascal. That is the value we are getting here. Okay, what is the option here? Option is D here, and here you need to observe. If I change the bording in the problem, for example, if the body is allowed up to 5 mm, if the body is allowed expansion up to 5 mm, then what is the amount of stress produced in this case? In that case, 0. Why? Because here what is happening? The amount of elongation that produced in the body because of the temperature rise is only 4.8, and the allowable expansion is up to 5 mm. That means still you can go 0.2 mm also. Still no one is going to restrict you, and unless otherwise some restriction to you, there is no stress produced in that. Okay, or instead of this, if I reduce the temperature to 50 degrees centigrade, then what happens? Instead of 40, if it is only 50, then 60 minus 20, 50 minus 20, 30. 30 into 12, how much is 3.6. In that case, what is happening? 3.6 mm it will become. 3.6 mm means it is less than the 4 mm free expansion. Even in that case, what is happening? There is no restriction for the free expansion of the body. If there is no restriction of the free expansion of body, then there is no stress. Okay, the same problem can be twisted in different ways. When you understand the concept, whichever way it will come, you can easily answer the question. Okay.